Hey everybody, welcome back. In this fourth and final step of Space Aliens in P5, we are going to be adding the following. We're going to add the ability to shoot lasers from the ship, pressing the space bar. And we're going to add a scoreboard at the top, keeps track of the score and the number of aliens left. One other thing we have to do to make this work, of course, is to learn how to add what's called collision detection, which is where we identify if two objects are touching each other, in this case, whether the lasers are touching the aliens, or an individual alien. And so we're going to do a lot of for loops, and we're going to have to add another class to our game called the laser class. So let's get started. Okay, the first step we want to take is add a new file. We're going to call it laser.js. In that blank new file, we're going to create a class called laser, capital L. Always capitalize your class names. And in there, of course, as usual, we're going to make a constructor method. Make sure you spell that properly. And while we're at it, making methods, let's also make a show method and a move method, similar to what we've done with the alien and ship. The constructor of our laser class will take two parameters, an x and a y. So we're going to have to say this.x gets x, this.y gets y. Now let's set the radius. Our laser is a small circle or ellipse, so it's going to have a radius. We'll set its radius to 5. We don't need to pass an argument in. We're going to make all of our lasers the same size. And just a comment that this is the radius. And let's go ahead and also create a property called diameter, or diam for diameter. And let's give it the value of this.r times 2, because we know that the radius times 2 is the diameter. And again, a comment here that this is the diameter. It's pretty obvious, but hey. And then one last thing, we're going to create what's called a flag. Okay, a flag is a Boolean variable, or Boolean property in this case. A Boolean holds only one of two values, true or false. And a flag is a Boolean property that kind of gets turned on or off based on the state of this object. So when a laser needs to be removed from the array, we're going to first set its flag here to true, meaning it needs to be deleted, and then later go ahead and delete it. And you'll see how to do that a little later. Okay, inside the show method, we're going to set this to have no stroke and a fill of kind of a pink color. You go ahead and choose whatever color you like, doesn't matter. And this is my pink here. And then we're going to just draw an ellipse. We know that an ellipse takes at least 4 arguments, this.x, this.y, this.diameter, and this.diameter. And there you go. Now, that's all it takes to draw our laser, just a little pink dot. And then now into the move method, we know we're going to cause the laser, when it's on the screen, it's going to always move straight up, and that's in a negative direction on the y-axis. So we're going to take this dot y gets this dot y minus, and we're just going to move it at a rate of about 20. And this will move it up on the y-axis, which is important that you understand the difference between the x and y axis and when you're going in a negative direction and when you're going in a positive direction. All right, that's it for now. We'll come back later and add some more methods to the laser class, but this should do it. We'll go ahead and save this, and we're going to go back to our sketch file. At the top of our sketch file, first thing we need to do is create another array called lasers, plural. This is going to hold all our laser objects, and initially here we'll just set it to a empty array, so use double square brackets. And this is an array of lasers, okay? And one last variable that we're going to need here in the program is points. And this is just going to keep track of our score, of course, and we'll set that to 0 when the game starts. Next, we need to add a key press event handler that will allow us to create a laser whenever we press the space bar on the keyboard. So our event handler should be down here near the bottom. First of all, I'm going to put a comment right here, end of draw function. Now, this is the global draw function. It's usually good when you have a big, long function like that to mark the end of it so that it's easy to kind of know where it begins and ends. All right, so here's my key event handlers I have for key pressed and key released. I want to, inside the key pressed, I want to add a little bit more code. We'll simply say if key equals the space bar, and so we put just a space in between two single quote marks. So if the key is the space key, then what we want to do is create a laser. We're going to call it var laser, and we're going to get a new capital L laser. This is going to use the class that we created earlier. And we know that we need to provide 4 arguments, an X and a Y. Actually, no, just 2 arguments, an X and a Y. But where do we want the laser to show up? Well, we want it to show up right where the ship is, but the ship is moving. Well, this is where the object-oriented programming gets to be so helpful, because we know we have in this sketch file, we have a variable called ship that we created earlier, and it holds the X and Y location of that ship on the screen. So all we have to do is say ship.x. And again, we don't use this .x because we're not inside the class file. We use ship.x, and we can simply go ship.x and ship.y. Okay? And that's going to create the new laser at that position. And then when we make the laser, we may have more than one laser on the screen at a time. So we need to take that lasers array that we created above, lasers dot, and there's a little array function called push. What push does is takes an object, whatever it is that you want to add to the array, and places it or adds it to the end of the array. So push adds objects to the end of the array. And there you go. Now we're going to take this laser we just created on line 68 and push it into the array. And now we can begin to use those. However, we aren't going to see our lasers yet until we call the show function or show method of the laser class. So let's go back up into our draw function. And again, this is the end of our draw function right here. We know that because if we click next to this curly brace, we see it starts up here on line 39, goes down to 58. And so inside that function, so go up a line, hit enter. Inside that function, we need to add some code for displaying and display and move the lasers. That's just a comment. Let me move this up a little bit so you can see it. Inside the global draw function, we need another for loop. Remember, with arrays, we use for loops a lot. Let's create a variable. This time, let's just call it LAS for laser, and it gets the value 0, while LAS is less than lasers, the array, dot length. This ensures that we go through the entire length of the array, all the objects. We don't know how many are in there at any given time, so we have to use the length of the array as our counter and increment by 1. And inside this for loop, we just simply say lasers, square bracket, LAS, that's our counter variable, and that's going to represent each laser in the array, dot show. Remember, we have a show method that we made in our laser class. And not only that, we can say lasers, square bracket, LAS, dot move, because we know we have a move method as well. All right. So just doing that, just doing those things, we should be able now to save this and test it. And let's see here. If we press our keyboard, it's not working. Great. Let's see what we did wrong. Whenever you have an error like that, the first thing you need to do is check your console. And I look in here and I see laser is not defined. Ah, that's right. I forgot to add the laser class to my index file. I think I do that every single time. That's okay. You got to learn how to find your errors and fix them. So we need to copy a line. The name of that file is laser_singular.js, and we can save and now test. If I press the space bar, I'm now getting my little lasers. So everything's working great. However, look at where the lasers are being drawn on the ship. They're coming out of the lower left or the upper left corner of the ship. So we need to adjust our code a little bit so that it comes out of the center. Come back to your key pressed function that we edited earlier. And instead of just drawing the laser at the X and Y, we need to edit this a little bit. The X and Y of a rectangle represents its upper left corner. And so that's why it's being, the laser is being created there. So what we can do is take the X and add to it, and in parentheses, put ship.width divided by 2. And that's going to give us half of the ship's value, and so we're adding half of the ship's width to that. The ship.y doesn't really need to change. Just by doing that, we see now that the lasers are coming out right out of the middle of the ship. Perfect. Now, you notice we don't have any collision detection yet. The lasers go right through those aliens. Again, nothing happens by magic, by automatic, right? Everything needs to happen because we've written the code for it. So we'll get to that later. Okay, now it's time to add the collision detection. So find your global draw function in the sketch.js file. Mine begins on about line 39. Go down to the end of that draw function and inside the loop that we made earlier, let's add code for collision detection. I like to put comments in here so I know what's happening. Right after lasers.show, lasers.move, we're going to create another for loop. So this is going to be a loop inside of a loop. So we're going to put for var. Let's use a different letter this time. How about J? For J equals or gets 0, while J is less than our aliens dot length. So we're going to loop through the entire array of aliens. So we're already looping through the lasers. Now we're going to loop through the aliens as well. J++. And we need to ask a statement. We need to ask if lasers, square bracket, LAS, so that's the current laser, dot hits, and then inside the hits method, we're going to give it a argument, and that's going to be the current alien, aliens, square bracket, J. Okay, so we've now asked the question if the current laser is hitting the current alien, and we're using a method called hits. However, we don't have a method called hits. We need to go back to our lasers class and add it. Back in our laser class, right below the move method, let's create a method called hits. And as we just discovered, we want to send an argument or a parameter into this method, and it's going to be an actual alien object. So let's just call it alien here. And now what we're going to do is figure out the distance by using what's called a distance function. This is built into P5. The distance function measures the distance, obviously, between 2 points. And a point is consists of a X and a Y. So this is how we would do it. Let's create a variable. Let's call it D for distance. Let's give it the value of dist. This is a built-in function, like I said, and it takes 2 points. So the first would be this.x, this.y. That's the laser because we're in the laser class. And then we're also going to say alien.x and alien.y. Now, normally we would not be able to refer to the alien here inside the laser class because we don't have access to it here. There's no alien variable here. However, we just passed in the alien variable here as an argument, and so now we can use it. So this is the power of passing arguments into other functions or methods. So what we're going to do is store in D the distance between the laser and the alien, and then ask a question. If D, that distance, is less than the radius of the current laser, and the adding that to the alien's radius, if the distance is less than those two radii, then we know that they're touching. We know that the alien and the laser are touching. So then what we can do is simply return true, meaning true, they are touching. And if the distance is not less, then we're going to say else and return false. Now, this is the first time we've seen a return statement. A return statement can be used in methods and functions if you want to return a value. And in this case, it's going to return true or false. Let's go back to our sketch file. And so, because we're using this inside an if statement, we're saying here, if it's true that a laser is hitting an alien, basically that's what's going to happen because it's going to return true or false there. If it's true that they're touching, then what do we want to do? We want to take that current laser from the lasers array. It's represented by the counter variable LAS, and we want to dot remove it and call that method. Now again, we don't have a remove method for our laser, so let's go back to our laser class again. So what we need to do is right here underneath our hits method that we just added, again, make sure you're not inside that method, but below it, let's add a new method. Remove method doesn't take any arguments, and all we have to do is say this dot to delete gets true. Now remember, we made a flag up here on line 7 called to delete. We set it to false because originally the lasers should not be deleted, but then once they have been collided with the alien, then we want to set this flag to true. This isn't going to actually make the lasers delete or be removed. We still have to do that inside our sketch file. Let's go back there. So after we run the remove method, what we're going to do is, let's add points. We have that points variable up at the top of the sketch file. Let's add some points to it. Let's say points gets points plus aliens square bracket j, which is our counter for the aliens here, dot PTS. So we're adding the points value of the aliens. Now, this is going back a few lessons. If we go back to our aliens class, remember, we gave each of the different types of aliens here on line 11 a various point value. That point value was passed in when we created each of the aliens. It's either 5 or 10, depending on which type of alien it is. Let's go back to sketch.js. So that's going to add either 5 or 10 to the current point value here in Sketch. And then one last thing, we're going to remove the current alien from the aliens array. This is how you do it. You give the name of the array, aliens.splice. Splice is a special array function, kind of like push, but the opposite of push. And it takes 2 arguments. First, the index number of the alien you want to remove, and then the number you want to remove. So from that point in the array, you can remove 1 or more aliens. We just want to remove 1. So we say aliens.splice parentheses j, comma 1. That's going to remove an alien from the array. Let's mark the end of some of our different curly braces. See, we have all these curly braces lining up here. This is the end of the alien loop that we were just using. And this here is the end of the laser loop. That's why it gets a little complicated as you go along here. Number 1. Why do I say number 1? Because I'm about to create another loop here, still inside the draw function. So make sure you're not outside the draw function. Let's go ahead and loop through lasers and remove lasers with flag. The flag set to true. That's what we just did earlier. Okay, so we're going to loop through the lasers again, but this time we're going to do it in a backwards direction, looping from the end of the array towards the beginning. This is how you do it. For var z, we'll just use a different letter this time. Gets, instead of 0, we're going to say lasers dot length minus 1. Remember, the length is always 1 more than the actual index of the last element, so minus 1, while z is greater than or equal to 0, and then say z minus minus. This is how you go through an array from the end to the beginning. Normally when you loop through an array, you go from the beginning to the end. And then we ask a question if lasers, square bracket z, dot to delete, remember that's our flag name, if that is true, we can say if that equals true, or we can just get rid of the equals true part. It's the same thing, just to say that, curly brace. Then we are going to do what we did earlier with the aliens. We're going to say lasers dot splice using the current counter variable z and remove one of them. And this is just remove laser from array. All right, so that's the end of the if statement. This is the end of laser loop number 2. We have this, and I start pressing. Look at that. Okay, this video is getting pretty long, but we're just about done. Here, right at the end of laser loop number 2, inside the global draw function, we need to add another little bit more code. First of all, we're going to call a function that I call update HUD. HUD stands for heads up display. It's kind of a gaming term. And so we're going to create that function in a minute. We're also going to check if game is over. And the game is over when all the aliens are gone. And so we are going to ask if aliens.length, that's the length of the array, if it is less than or equal to 0, that means there are no more aliens in the array. And so we know they have all been removed and disposed of. And if that's true, let's call game over. Again, another function we have to create. Still in our sketch file, let's go ahead down below all the event handlers that we created earlier. Let's add some empty lines. This is down below everything else in the game in the sketch file. Let's go ahead and add a function called update HUD. And below that, a function called game over. Neither of those functions take any arguments. So when we call update HUD, what we're doing is setting the fill to white, using the text function to write the word score, :space, end of quote, plus the variable points, which holds our current point value, and then we have to give it an X and a Y. We also want to, on that same in that same area of the screen, write aliens remaining, :space, end of quote, outside the quote, plus the length of the aliens array. This is going to tell us the current status of the array, how many aliens are left. We're going to put this at about 70, 20. Let's test this and see if it works. Now we can see that the score is up on the top of the screen, aliens remaining. I just removed 2, so there are 10 left. Now there's 9 left. Remember, the bottom row of aliens is worth 5 points, so I get 5 points when I remove one of those and 10 points when I remove an alien from the top row. It's working perfect. For our game over function, what we want to do is set the background color to 0, set the text size to a really large size, maybe 72, do text align, all caps center, then use the text function to write the word in all caps again, game over. And we're going to set this at the width divided by 2, center of the screen on the x-axis, height divided by 2, also on the center that direction. And the last thing to get the game to stop looping, stop running, remember our draw function is always looping. We can say no capital L loop, no loop. It's a function, so we need parentheses, semicolon, and that should stop the game. Again, this is going to happen. Let's go back up to our draw function and the logic we added. If the alien's length is less than or equal to 0, game over. Let's test it. Playing the game now. Again, collision detection is working perfectly. The number of aliens is being displayed on the screen, and the number remaining. And the points value are being added accurately. Again, the bottom alien's worth 5 points, the top alien's worth 10. As soon as I hit the last alien right now, I should get the game over screen. And the loop of the game stops, and there you have it. A working, simple Space Invaders game made with P5. And you've learned hopefully a lot about object-oriented programming and about how to use classes and how to use collision detection, etc. Hope this has been fun for you. If so, like the video, that'd be great. Maybe subscribe to the channel. It's been great having you for this series of videos, and I'll see you next time. Thanks, bye.